Hey guys, welcome back to the channel. We're still on Leetcode 33, searching with a rotated sorted array. We've solved this with a few different methods. The last one was using kind of like a double binary search. Today we're gonna step through this code and actually visualize how it works. So I've taken the liberty of copying and pasting this code. This is the exact same code. I created a driver code based off the example one that was given to us. Let's go ahead and run it and see what's going on. So we're gonna step, okay, we declare a function. We define nums, okay, nums is this guy. We define our target is 0, and we call our function, okay. So now we're back in the loop of the function. Okay, first is we're gonna define n is just the length of the function. In this case, there's 7 elements in nums, so n is the length of nums, I'm sorry. So n is gonna be 7, okay. We define n as 7, okay, good. Then we're gonna define our left or right pointers, okay, which is gonna be 0 and 7 minus 1, which is 0 and 6. Okay, we have our left and right pointers. Then our while loop. While L is less than R, is L less than R? Yes, it is. L is 0, R is 6. So we're going to calculate our mid, which is just going to be 6 plus 0 divided by 2, which our midpoint is going to be 3. Okay, we have mid. So now first, if num of mid is greater than num of R, okay, num of mid is 3. Num of mid is 7, okay, because 7 is the third index, okay. Num of mid is greater than num of R. R is 6, okay. Num of 6 is 2. Is 7 greater than 2? The answer is yes. So we're going to go in this if block and increment our left pointer. So our left pointer is going to stop. Right now it's pointing at 0, but it's going to move to mid plus 1. Mid is 3. So our left pointer is going to point here at the fourth index, so which is element of 0. So let's go ahead and see that happen. Okay, boom, our left pointer has been updated to 4, which is mid plus 1, okay. So now we're back at the top of the while loop again. Is L still less than R? Yes, R is 6, L is 4, okay. So calculate our new mid. Our new mid is just L plus R, which is 6 plus 4, which is 10. 4 divided by 2, so our mid is going to be 5. Okay, we calculated our mid. Okay, now, is nums of mid still greater than nums of R? Nums of mid is 5. What's nums of 5? Nums of 5 is 1. What's nums of R? 6. Nums of 6 is 2. Is 1 greater than 2? The answer is no. So we're not going to go in this if block. We're going to go in the else block instead. Okay, and set R equals mid. So watch our R is going to change to our mid, which is 5. Okay, boom. We've updated R. Okay, now we're back at the top. Okay, is L still less than R? Yes, L is 4. R is 5. Okay, that's less. So we're going to go back in here and calculate our mid. Mid is just going to be 4 plus 5, which is 9. Floor divided by 2. 9 floor divided by 2 is 4. So our mid is going to be 4. Okay. So see how from this array with 7 items, we're now down to an array just with 2 items because our left pointer is at index 4 and our right pointer is at index 5. So we're literally only looking at these 2 items right now. Okay. So now, okay, next we're going to say, is nums of mid greater than nums of R? What is mid? Mid is 4. Is nums of 4 greater than nums of 5? The answer is no. Nums of 4 is 0. Nums of 5 is 1. So it's not greater. So we're going to go in the else block and move our right pointer from here to mid. Okay. So now all of these guys, left, right, and mid, are going to be all 4s. Okay. Bam. 4, 4, 4, 4. So now, is left pointer still less than right pointer? Obviously no. Left pointer is equal to right pointer because they're both 4. Okay. So we're going to jump out of this while loop. We're going to pop out. Okay, good. So then we set our pivot to left. So our pivot now is 4. Okay, good. So now we're going to go into our second binary search loop. We're going to reinitialize our L and our R variables back to what they were, which is 0 and 6. Okay, bam. L and R reinitialized back to 0 and 6. Okay, so now we're going to go to our while loop. Is L less than or equal to R? Yes, it is. L is 0, R is 6. So we're going to go in here. We're going to calculate our mid again. Mid is going to be 6 divided by 2, which is 3. Okay, so let's go ahead and do that. Okay, our mid updated to 3. So now here's the fun part. We're going to calculate our mid 2, which is the second mid, just to kind of keep track of what is the center of the array if we kind of unravel the array. And I'm going to show you what I mean by that. Okay, this is our previous example. Let's do it again. So our mid is just saying in this array, if we unravel this array, okay, if we sort it, okay, but we don't rotate it. keep in mind there's no 3 in there. If we sort it but we don't rotate it, actually let me write it better so it kind of like matches with with this. Okay, so 0 is right here, 1 is right here, 2 is right here, 3 is right here, 4 is right here, 5 is right here. Oh, I'm sorry, there's no 3. So 4, 5, 6, and 7. Okay, if we sort it but don't rotate it, what is the middle? Okay, this guy is mid 2. Okay, the middle is going to be 4. Okay, and in this case, which is right here in our original, so our mid 2 starting off is going to be 0. Okay, that's kind of what we're doing with mid 2. Okay, so we want to calculate mid 2. It's just mid plus pivot. Okay, 3 plus 4, that's 7. Modulus and 7 modulus 7 is 0. There's no remainder once you divide 7 with 7. So mid is 0. Like we said, it's the first element. Mid is 0 starting off. Okay, so now we have this guy. So if norms of mid equal target, norms of mid is not equal to target, right? No, norms of mid 2, okay, because mid 2 is 0. So norms of mid 2 is 4. That's not a target. We're looking for 0. So we're gonna jump out of this loop to else if. Okay, if norms of mid 2 is less than target, norms of mid 2 is not less than target, he's 4, target is 0, he's greater. So we're gonna jump to our else block, okay, and just increment our move our right. So our right pointer is gonna change from 6 to 3 minus 1, right? So it's 2. So that's what should happen. Okay, good. So now we're left with 0 and 2. Okay, we're back at the while loop. 0 and 2. Okay, is L still less than R? Correct. Let's calculate our mid. Our mid is just going to be 2. It's just going to be 2 divided by 2, which is 1. Okay, good. Now let's calculate our mid 2. Okay, our mid 2 is 5, right? Because it's mid, which is 1, plus pivot, which is 4, plus 5. 5 modulus 7 is 5. Okay, so our mid 2 is 5. So we're now looking at the 5th index 1. Okay, we're looking here right now. So we're saying, is mid 2 equal target? No. Norms of 5 is 1. Okay, so it's not. So we're not gonna go in this if block. I'll see if is mid 2 less than target? No. Norms of mid 2 is greater than target. Okay, he's 1, target is 0. So we're gonna go in the else block. And we're gonna move our right one more time. Okay, we're gonna move our right to 0. So let's see. Fine. So left is at 0, right is at 0. Okay, mid is at 1. Is left still less than or equal to right? Yeah, they're equal, 0, 0. So we're gonna go in this while loop one more time. So now we calculate our mid. Mid between 0 and 0 is just 0. So our mid is just 0. So now our mid 2 is now 0 plus pivot is 4 modulus n. So that's just 4. That gives us 4. So mid 2 is 4. So now, is norms of mid 2 equal target? Okay, mid 2 is 4. Norms of mid 2 is 0. Is that equal our target? The answer is yes, it is equal, right? Because our target is 0. So we're just gonna return mid 2. Bam, we return 4. That's the index of what we're looking for. That's it for the video, guys. I hope it was straightforward in helping us understand how this problem works with using a double binary search. And I'll see you in the next one.